Visualize a mesmerizing celestial ensemble directed by an unending legion of stars. Planets, astral beings, and moons, each operating in complete harmony. Within this cosmic mosaic resides a category that has intrigued astronomers for generations. Exoplanets. These enigmatic spheres outside our solar system are hidden away in the vast Milky Way galaxy. You might be surprised by this. Among the numerous astronomical bodies, an exoplanet exists so strikingly analogous to Earth, so eerily recognizable that it might serve as our planetary duplicate. Take a trip with us as we investigate the captivating domain of Proxima b, a world situated only 4.2 light-years away from Earth. The James Webb Space Telescope JWST is changing the way we interpret these remote orbs. Picture your imagination drifting across the vast panorama of the Milky Way. From the heavens, a galaxy overflowing with more than billions of exoplanets. To recognize the scale, imagine each exoplanet as small as a tiny grain of sand. The Grand Canyon could hold that many, and still be sufficient to create a brand new natural wonder, a Grand Canyon 2.0, approximately 4 million kilometers in length. More astonishing still, approximately 20% of these distant planets are deemed Earth-like, considering their atmospheric and geological characteristics. That means for every 5 exoplanets, one might mirror our homeworld's traits. However, the story doesn't end there. Orbiting many of these worlds could be another billion moons, rocky satellites resembling our own, engaged in a gravitational dance with their parent planets, according to space.com. If you're searching for proof of another celestial body that can support life, or is already doing so, the universe presents boundless potential. Given that the enormity of the cosmos is being unveiled, it's time to give the master spotlight to the instrument that can capture its exquisite subtleties, the James Webb Space Telescope. This heavenly examiner, outfitted with a mirror instead of a lens, surpasses even the most advanced imaging processes. Its 6.5-meter primary mirror, 2.7 times larger than Hubble's, empowers it to detect the faintest stellar flickers billions of miles away, and to examine the planets that surround them. However, JWST is groundbreaking, not just for its unrivaled observational might. Its cutting-edge elements, such as infrared detectors and spectroscopic apparatus, also set it apart. These tools do more than merely observe. They examine specific light wavelengths emitted or reflected by cosmic objects to determine atmospheric composition, chemical structure, density, and mass. Functioning like celestial forensic analysts, they can determine whether a planet contains carbon-based molecules, water, or even breathable air. JWST isn't simply a superior incarnation of Hubble, it marks a monumental leap forward. If Hubble's findings inspired AEW, prepare yourself for an entirely new sphere of insight. As we probe deeper into the universe's nuances, one stellar system in particular commands our attention: Proxima b. Sense. Its discovery in 2016. This enthralling planet has evolved into the central character in a cosmic story, brimming with mysteries and contradictions that have captivated scientists and space enthusiasts alike. What makes Proxima b special? Firstly, it resides in our celestial vicinity, just 4.2 light-years away. It's contextualized at light speed. Few could arrive at Proxima b in just over 4 years, similar to the length of a presidential term or the duration of a fleeting fashion trend. However, its proximity provides more than just convenience. In a universe that spans 93 billion light-years, locating a world this near and this rich in potential is like uncovering a precious gem among a mountain of debris. This gem might hold crucial clues about life and our position in the cosmic narrative. The attraction to Proxima b is not confined to its location. Scientists hypothesize it could not only resemble Earth, but act as Earth's reflection. Earth 2.0, situated in its star's habitable zone, where conditions are ideal. It may support liquid water, Envision alien waterfalls cascading down steep escarpments, vast rivers meandering across uncharted terrain, immense oceans as deep and mysterious as the Mariana Trench. However, before packing our imaginary suitcases for a visionary trip to Proxima b, we must scrutinize some of its peculiar characteristics. Take, for instance, the fact that one day on Proxima b lasts over 11 Earth days. Imagine a dawn that gradually takes many hours to complete, followed by prolonged sunsets suffused in amber hues. Though visually poetic, this prompts essential questions about temperature and habitability. Might the human organism adapt to such prolonged cycles of illumination and darkness? Would we need to alter our diets or sleep cycles? Would our perception of time shift? What would life on Proxima b be like, simultaneously frighteningly similar and entirely alien? Nature offers a paradoxical world surrounded by contradiction. Could life on Proxima b resemble ours? This inquiry challenges the very foundation of what we deem a livable planet. The James Webb Space Telescope is not merely an instrument tits an academic juggernaut. But how can we obtain accurate and reliable information about a planet we've never physically set foot on? JWST employs all its technological prowess to address this question. Working as an orbital laboratory, thanks to its innovative design, scientists are no longer satisfied with merely observing. They can now probe these remote worlds in depth, utilizing cutting-edge tools, using light, infrared sensors, spectrographs, and the telescope's precision. JWST examines the energy from electromagnetic waves, revealing secrets light years away. Planets far away emit or reflect light. By dissecting the specific wavelengths that diverse chemicals absorb or release in a planet's atmosphere, researchers can successfully carry out a remote biopsy of these other worlds. They are able to determine the pressure in the air, its thickness, and the likelihood of elements that support life, such as water vapor, oxygen, carbon compounds, and more. JWST is more than just another telescope. It is a significant development in analytical ingenuity. It grants scientists the ability to replace speculative claims with verified knowledge, altering our comprehension of the universe and allowing us to envision a future beyond Earth as attainable. Just when we thought the universe was complete, lacking any additional surprises, something astonishing happened. Astronomers using JWST discovered an unforeseen energy pulse emitted by Proxima b, so individual and intricately structured that it resonated throughout the scientific community and sparked viral discussion online. It rekindled the query, are we alone? This anomaly in the electromagnetic field was unlike anything previously recorded. Its configuration was so extremely accurate and repetitive that it suggested intention, conceivably the work of an expert intelligence. For just a moment, the collective imagination of humanity paused, electrified by the notion that another form of consciousness could be extending its hand into the void. But then, just as mysteriously as it appeared, the signal vanished, causing an odd silence, speculative ripples, and a great deal of unsolved mystery. Was it merely rare cosmic noise, a transient anomaly in the immensity of space? Or was it something more, a subtle communication from a knowledgeable civilization other than our own? Could it have been a long-range or coded vicuna, buried reminder of an ancient civilization trying to speak across epochs? That one signal, in all its simplicity, transformed Proxima b from a mere subject of astronomy into the emblem of our expectations, fears, and awe. It evolved from a promising planet into a symbol of possibility. The repercussions are colossal. Could this be part of a broader, more intricate narrative, one that links us to a wide range of kin across the stars? While certainty remains elusive, one thing is undeniable: our curiosity only grows. It fuels not just scientific inquiry, but our fundamental human yearning to reach out and discover that we are part of a much bigger whole, the artificial luminescence of the next frontier in extraterrestrial exploration adds a new dimension to this journey. Our saga does not conclude here. JWST end. The new technologies that emerge are no longer passive. They are being reimagined as engines for cosmic investigation. Forward-thinking scientists now envision them as night vision apparatuses across the stars with the daring objective to search exoplanets for more than just natural indicators, but also for signs of human-caused illumination. Indeed, streetlights, synthetic lighting, cityscapes, vast megalopolises glowing beneath alien skies. Imagine the marvel of flourishing extraterrestrial civilization radiating energy into space, not detectable through organic signatures, but visible through their engineered glow. A glimmering cityscape on the shadowed portion of a faraway planet. A man-made light shining through the darkness of deep space, though it calls to mind science fiction. This idea is quickly entering the realm of scientific plausibility. Recognizing artificial light would not only indicate intelligent life, but reveal something cosmically organized, something with rhythm. Like life, intelligence could be a common theme woven throughout the stars. What would such an announcement entail for us? Beliefs would be altered. Spiritual principles and global geopolitics would be rethought. Our understanding of science would be revolutionized in a single historical moment. Humanity could shift from isolated inhabitants of a blue sphere to recognized members of a larger, possibly ancient civilization within the universe. The questions would become deeper than ever before. How should we initiate communication? What knowledge might they offer? And most provocatively, what stories would we tell them? Therefore, as the James Webb Space Telescope peers farther than any observer before it, and as we improve our instruments to pick up even the faintest signals, one truth continues to echo from the void. The cosmos is no longer silent. It's mumbling, maybe even speaking. The question remains, are we ready to respond?